All right, let's do this. It's all joking until the grade comes back. It's all joking until it comes back. All right, let's do it. Let me put this up here first. You don't need to put this in your notes. I'm just going to draw a random angle up here and just put a 70 in there. Finish this for me. Your whole entire math lives, if you had an angle measure, you'd always say it was in 70. That's the only type of units you know until today. There's actually another way to measure an angle. All right? Just like your desk, you can measure it in what? Inches, feet, centimeters, millimeters, right? But for an angle, you can measure it in degrees, or what I'm going to introduce today is you can measure it in what's called radians. All right, radians. I don't know if you guys remember our SOHCAHTOA days, when I'd say before we start every day, make sure your calculator's in degree mode. Don't change it. Don't leave them. You don't need to change them. Did you ever notice what the word was next to it? Yeah, it's radians, because those are the two different ways to measure an angle. Your calculator, leave it in degree mode. It should never be in radians until you go to Algebra 2 if you make it next year. Okay? So it should never be in radians until next year in Algebra 2. So what we're going to talk about today is, hey, how do I go from a degree to a radian? How do I go from a radian to a degree? And I know, why do I need this? I get it. Let me go back to this length of arc formula I introduced to you yesterday. What goes in for measure of the arc? Yeah, which is also in what unit? Degrees. But what if I now give you an angle that's in radians? You can't use that formula unless you know how to convert that back to degrees. All right, because what you plug into here has to be in degrees. But what if it's in radians? You can't plug it in. It's got to be converted into degrees. All right, so here we go. How do I take an angle and go from degrees to radians? Good news, you don't have to memorize this. Go to the back of your packet for me, please. We have not used this at all this year. The only time I think we've used the formula sheet is some of you guys that don't like to factor use the quadratic formula on there. That was it. That's all we've used it for. But we're going to get a little bit more use out of it today. So right now, we're going to go start in degrees. So everyone look at the column that starts with the word degrees. Next to it, it says, all right, here's how many radians are in 1 degree. Everyone see that right there? It's what? Pi over 180. Correct. So that's how we're going to convert a degree into a radian measure. We're going to multiply the degree by pi over 180. That's how we're going to finish it. So that's how I go from a degree measure of an angle to a radian measure of an angle. All right, let's try it out. 30 degrees. What would it be in radian measure then? Radian measure. And you'll see how they kind of compare. So 30 times pi over 180. Now, please don't go to your calculator yet. I will do it up here and show you what, and you'll know right away why I'm going to have a problem. You guys have known me now for many months. All right, ready? 30 times pi over 180. Perfect. All right, that's how many radians there are. What am I going to have an issue with? Think I'm going to have you write that down on your paper as a final answer? No, and I'm not going to have you round it either. All right, it's about half a radian. All right, 30 degrees is about equivalent to half a radian, but I don't want that sloppy long decimal down. So instead, we're going to clean it up. And anytime you're going to leave a radian answer for me, I would like you to leave it in terms of pi, please. Leave it in terms of pi so it's a little bit cleaner looking. So how do I do that? Well, I'm going to leave pi in my answer. And all I need you guys to do is take 30 over 180 and reduce it for me. So 30 degrees, an angle of 30 degrees has the same measure as an angle of 1 pi over 6. All right? And remember, that's about half a radian we just saw. So 30 degrees is about half a radian. But I just wanted it to look a little bit cleaner, and you'll see this written out too. All right, let's go. One doesn't make you great. Let's go to 45 degrees. So if I have an angle of 45 degrees, pi over 180. Again, anytime you're leaving a radian measure for me, leave the pi in your answer. What does 45 reduce down to? 27? 1 pi over 4. Go ahead and try 3 and 4 on your own. I'll even keep this joke going further. Why are some of you even using calculators? This should be an easy calculation. You guys can do all the decimals times pi in your head. This should be easy. Why are we touching it? Come on now. Come on now, guys. Come on. Too soon? Sorry, too soon? Truth hurts. How about 60 degrees? What'd that turn into? 24? 1 pi over 3. And then how about 90 degrees? What did that turn into? 18? 1 pi over 2. Good. Also, I probably picked bet. I should have added in a different example than those 4. It doesn't have to be 1 pi over something. You might get 2 pi over 3, 6 pi over. It might be 6 pi over 2. All right. You might get something else. All right. So just don't assume it's just going to be the 1 pi. All right. We go this way. We got to go backwards. What if I give you a radian and let's turn it back into degrees so I can use this formula now? All right. I know an angle's in radians, but darn it, I can't find the length of an arc unless it's in degrees. Sorry, I just gypped you guys there. Here you go. Sorry, just gypped you. Here you go. Go back to your formula sheet. Now you start in radians. So look on your formula sheet where it starts in radians in the column. Everyone see where it says radians. That's where I know where to go on the, that's how I know which one to use, whatever I start out with. And what's it saying? Multiply by? Not pi over 180 anymore, but 180 over pi. And watch the magic that happens here. So number 5, I have 7 pi over 6 radians in an angle. How many degrees would that be? So I take it, multiply by 180 over pi. Oh! What's in the numerator and denominator that are going to nicely cancel out? Pi's are gone. And this, oh, it's going to drive, it drives me insane. Does anybody see an equal sign between these two? Me neither. Why do I say that? We don't cross multiply. No, stop, leave, actually. All right, leave, that's embarrassing. Cross multiplication is when 2 fractions are equal to each other. I am just simply multiplying here. 7 times 180 over 6, or just do 7 6 times 180 in your calculator. There's no cross multiplying unless an equal sign exists. How many degrees in 7 pi over 6? 7? 210. Go ahead, 6 and 7, and then we'll do 8 as a group because 8's a unique one. 3 pi over 5 radians. How many degrees you looking at? 13? 108. Good work. And then finally, 5 pi over 3. How many degrees are we looking at there? 4? 300. Yep. Good work. Last one. Just because an angle's in radians doesn't mean you're going to see a pi. Remember, the only purpose of pi does, it just cleans it up over that sloppy decimal, right? That's the only reason why we're leaving everything in terms of pi, is because we don't want to see all the long decimals. Doesn't have to have pi, though. So if there's no pi, don't add it in. So what do I do with an angle of 3 radians? Same thing I've been doing. I multiply it by 180 over pi. Only difference? Pi going anywhere? No. Don't add a pi in. 3 pi is different than 3. Don't add a pi in. The pi's won't cancel. So I just go to my calculator. 3 times 180 over pi. And you know what? Let's round this to the nearest tenth. So yes, a radian doesn't have to have a pi with it. The only reason it's there is so we don't have to write that long decimal. Nearest tenth. When you're ready, 21.
171.9.
Leave your packet right where it is. Grab your Chromebooks if you have them, please. I just want to do a quick check here to make sure you can do something. Because Thursday night's assignment is not in the textbook or in your packet. So I want to make sure we are good for Thursday night. So let's do this now while we have some extra time. Can everyone log on to Delta Math? Because if not, and you need my teacher code, then we're going to take care of that now. If you can log in to Delta Math, make sure you can find the quiz review for Unit 10. If you can, you're good to go for Thursday, and you can close your Chromebook and put it back. If not, you need to log in. I want to do it now. And we're still not done with class either. Make sure you can. I don't know what I named it. Unit quiz review 1, quiz number 1 review, Unit 10. Can everyone get into Delta Math? Can everyone see the assignment for Thursday night there? That'll be for Thursday night. That's how you're going to get ready for your quiz. All right, if you can, close them up. There's no other reason to be in there. The homework's out of the packet tonight, and I'm going to post the answers up here. So everyone's good? Go to your homework. I got to talk about the last problem. Max, we good here or not? What do you need? Okay. All right. I want to make sure we're going with number 9. Okay, I want to make sure we are clear on number 9 tonight. What I'm asking, I'm not going to tell you how to do it, but what it's asking at least. Okay, so number 9, I got my clock up here. You're going to do this in degrees and radians. You're going to find the angle, the hour hand. Everyone's familiar with the hour hand? I ask, and I'm serious because we're all digital nowadays. So hour hand right here, the orange hand. What angle does it move through as it goes from 1 p.m. to 9 p.m.? All right, so here, from here to here. What is that angle right there in degrees, and what is it in radians? And I'm giving you a hint that every time it moves a minute, it goes 6 degrees on a clock. And what do I mean by that? So as it goes from 1 to this tick mark right here, it just went 6 degrees. As it moves to the next tick mark, another 6 degrees. Okay? What I want to know is, how far does it go from 1 to 9 in degrees and also in radians? And I'll leave it at that for you guys to think about. Okay, but I'm giving you a hint. Every time it goes a minute on the clock, it moves 6 degrees. All right, so you guys get to it, work with each other. I will put the answer key up here. And just letting you know, I did that clock problem maybe a little differently than you're going to approach it. Great. As long as we get to the final answer.